Hello everyone, we are again together for a new class. Today we will discuss the important topic regarding our important chapter thermodynamics. Actually, we are going to discuss important MCQs regarding thermodynamic. So we should start the equation from first question. Question number one. First is gas law are applicable to gas as well as vapors. Option B is gas alone and not to vapors. Option C is gas and steam. And option D is gas and vapor under certain conditions. So the right option from these four options, there is a option B, which is correct. Gas alone and not two vapors. Question number two, Carnot cycle consists of two constant volume and two reversible adiabatic processes. And option B is two isothermal and two reversible adiabatic processes. And option C is two constant pressure and two reversible adiabatic processes. And option D is one constant volume and one constant pressure and two isothermal adiabatic processes. Is we know that Carnot cycles consist of four processes. Two are isothermal reversible and two are adiabatic reversible processes. And so the right option is option B, two isothermal and two reversible adiabatic processes. Which one of the following law is applicable for the behavior of perfect gas? Boyle law, Charles law. Option C is gas logic law, and D is all of above. So the right option is option D. An ideal gas is compared to real gas at very high pressure, occupy more volume, less volume, same volume, none of above. So an ideal gas is compared to real gas at very high pressure, occupy less volume. So the correct option is B, is less volume. So, if we talk about the question number five, the efficiency of Carnot cycle may be increased by increasing the highest temperature, decreasing the highest temperature, C, increasing the lowest temperature, and D is increasing the lowest temperature. So, the right option from these four options is C, increasing the lowest temperature. And for question six, according to kinetic theory of the gases, the absolute zero is attained when volume of a gas is zero, when pressure of a gas is zero. Option C is kinetic energy of a molecule is zero, and option D is specific heat of a gas is zero. So the right option is D, specific heat of a gas is zero. So the right option is very close to that statement about the specific heat of a gas, which is zero for the absolute temperature. And for question 7, which one following statement is false? Spark is a state function, temperature is a state function, and option C is change in state is completely defined when the initial and final state are specified. And option D is work appear at boundary of the system. So the right option from these four options, which one is first? The first option is correct option. Work is a state function. That is not true because work is a path function. And for question 8, molar heat capacity of a battery is equilibrium with the ice at constant pressure is 0, infinity, and option C is 40.45 kilojoule per Kelvin per mole, and option D is 75.48 joule per Kelvin per mole. So the right option from these four options is actually the molar heat capacity of a battery in equilibrium with the ice at constant temperature is infinity. The right option is B. For the reaction C3AH8 plus 5H2 going to a product which is carbon dioxide gas plus water molecule, for water molecule at constant temperature, then the change in enthalpy minus change in energy is equal to plus RT Option B is minus 3RT plus C. C option is plus 3RT and option D is minus RT. So the right option from these four options is option B, del H minus change in energy is equal to minus 3RT. Further, question number 10, the heat required to rise the temperature of a body by 1 Kelvin is called specific heat, thermal heat capacity, thermal heat, water equivalent, or molar heat capacity. So from these options, the correct option is thermal capacity. The heat required to rise the temperature of a body by 1 Kelvin is called thermal capacity. For question 11, in which of the following process the process is always non-feasible? Option A is change in enthalpy greater than zero and change in entropy greater than zero. Option B is change in enthalpy is less than zero and change in entropy is greater than zero. For option third, del H greater than zero or change in enthalpy is greater than zero and change in entropy is less than zero. For option D, del H or change in enthalpy is less than zero and change in entropy is less than zero. So the right option is that the process is not feasible rate when change in enthalpy is greater than zero and change in entropy is less than zero. So the right option is option C. For 12 question, internal energy does not include first A, nuclear energy, option B, vibrational energy, C is rotational energy, option D is energy of gravitational pull. So the right option, these four options, actually internal energy is a include of nuclear energy, vibrational energy, rotational energy, translational energy, but not include the energy of a gravitational pull. So the correct option is energy of gravitational pull, which is not include part of internal energy. So the right option is option D. For question 13, adiabatic expansion of a gas always has decrease in temperature. Change in heat is equal to zero or heat is equal to zero. Option C is work is equal to zero and option D is change in enthalpy is equal to zero. So the right option is option B, change in heat or heat is equal to zero for adiabatic processes. For question 14, for an endothermic reaction, del H is positive and reaction is feasible when TDS greater than del H. Reaction is feasible when del H is greater than TDS, and option C is feasible at all temperature and option D not feasible at all. So the only process is feasible when TDS greater than del H. It is not feasible at del H greater than TDS. It also not feasible at all temperature. It only feasible at the same temperature. So and also it not feasible at all. So the right option is option A. Which one following is not a state function? Del H is a state function. Del E is also state function. Work is not a state function. So and enthalpy is also a state function. So the right option is option C, because work is not a state function. Work is a path function. And for question 16, the unit of entropy is joule, and option B is joule per mole, option C is joule per Kelvin, and option D is joule per gram. And the right option from these four is C, joule per Kelvin is a right option, which is in unit of entropy. For 17 question, for 17, in a closed system there is no exchange of mass. Here is it should be mass and but the exchange is exchange of dash is possible between the system and surrounding. Here is mass and here is energy is possible between the system and surrounding for a closed system. And for question 18, when there is no exchange of heat taking place between the system and surrounding, it is said to be undergo dash process. It is a isothermal process. It went to that direction should be a isothermal reaction or isothermal process where there is no exchange of heat take place between the system and surrounding, which is a isothermal process. And for question 19, an open system is one in which a mass does not cross the boundary of a system through energy may do so. And option B is neither mass and nor energy can cross the boundary of a system. And option C, both energy and mass can cross the boundary of a system. And option D, mass crosses the boundary but not the energy. So the right option is uh, C, both energy and mass can cross the boundary of a system which is called an open system where both energy and mass can transfer from system to surrounding. For question number 20, specific heat of air at constant pressure is equal to 0.7, 0.21, 0.24. I think the option 4 option is missing, which is a correct option because this option is not correct in my calculation. So the option D is a correct option which is missing here. And for question 21, crystalline gas constant of a gas is equal to molar heat capacity at constant pressure divided by molar heat capacity at constant volume. And option B is molar heat capacity at constant volume divided by molar heat capacity at constant pressure. And option C is molar heat capacity at constant pressure minus molar heat capacity at constant volume. And D is molar heat capacity at constant pressure plus molar heat capacity at constant volume. So the right option is option C. Molar heat capacity at constant pressure minus molar heat capacity at constant volume is equal to gas constant R. So the right option is option C. For question 22, gas law can be fully determined by first law of thermodynamic, option B, second law of thermodynamic, and option C is third law of thermodynamic, and option D is a fourth law of thermodynamic. So the correct option from these option is option D. Gas law can be fully determined with fourth law of thermodynamic. For question 23, change in enthalpy of a system is a heat supplied for constant pressure, constant temperature, constant volume, and constant entropy is a fourth option. But so the change in enthalpy of system is heat supplied for the constant pressures. The option number A is correct option. Change in enthalpy of system is a heat supplied for the constant temperature, constant pressure. For question 24, zero law of thermodynamic stated that deal with the conversion of mass and energy, deals with the reversibility and irreversibility of the process. And option C is stated that if two systems are both in equilibrium with the third party, then they are in thermal equilibrium with each other. And option deal with the heat engine. Actually, zeroth law of thermodynamic deal with the it stated that two systems are in equilibrium then with the third system they are all in thermal equilibrium with each other. That is statement is correct about the zeroth law of thermodynamic. So the option C is the correct option. For question 25, enthalpy of combustion is always positive, always negative, always zero, always infinity. So the correct option is option B. Enthalpy of a combustion is always negative. For question 26, decomposition of sodium chloride into sodium ion and chloride and release energy of 788 kilojoule per mole. What is the energy called? It is called lattice energy, translation energy, dilution energy, neutralization energy. Actually, this energy is called lattice energy. So the first A is a right option for this question. For 27, which one of the following is not a spontaneous process? Actually, there are many here in the option. There are many options which are not, which are spontaneous, such like sugar dissolving water is also spontaneous. rusting of iron is also spontaneous. Evaporation of water is also spontaneous. Only the melting of the iron is non-spontaneous reaction. So option B is a right option. Smelting of iron is a non-spontaneous processes. So for question 28, spontaneous reaction that occur are mostly in the nature in endothermic nature or exothermic nature or both endo and exothermic nature, and option D is neither exothermic nor endothermic nature. The actually is spontaneous reaction occur mainly on exothermic nature. And for question 29, the entropy increase for a spontaneous reaction, which is actually true. So entropy increase for the spontaneous reaction. Option A is a correct option. For question number 13, the melting of ice into liquid water is an example of tube dash reaction, endogenic reaction, exogenic reaction, exothermic reaction, endothermic reaction. Actually, melting of ice into liquid water is an example of exothermic reaction. And for question 31, the Gibbs free energy is a positive when a change in enthalpy and change in entropy are positive at high temperature. Option B is low temperature. Option C at all temperature, and option D is only at 0 Kelvin. So the right option is that at low temperature, the Gibbs free energy is positive, and change in enthalpy and change in entropy are positive at low temperature. And for 32, question number 32, in equation del H is equal to minus 2.303 RT log K. What is a K? Actually, it can be a change in temperature or Kelvin, or it is option C is a equilibrium constant, and option D is change in enthalpies. So the right option is option C, equilibrium constant. Further, the compressibility factor Z for the non-ideal gas is zero, is equal to zero or less than one or greater than one or equal to one. Actually, the compressibility factor for non-ideal gas is greater than one. So the right option is C. For question 34, which is not true about the thermodynamic, first option is it is ignore the internal structure of the atom and molecule. Option B is it involve the matter in bulk, and option C is it is concerned only with the initial and final state of a system, and option D it is not applicable to the macroscopic system. So the right option from regarding the thermodynamic, actually this is for option 4 is not related to the thermodynamic. It is not applicable to the macroscopic system, which is not related to the thermodynamic. And for question number 35, a system that can transfer neither matter nor energy to and from its surrounding is called a closed system or isolated system or open system or homogeneous system. Actually, option B is correct option, where like isolated system where mass and energy cannot be transferred from system to surrounding. So the right option is option B. For question 36, an intensive properties does not depend upon the nature of substance or quantity of a matter or external temperature or atmospheric pressure. So the right option, the extensive property does not depend upon the quantity of matter. So it is B is a right option from these four options. For question 37, the mathematical relation for the first law of thermodynamics is del change in energy is equal to heat minus work, or change in energy is equal to zero for a cyclic process, or change in energy is equal to heat for an acyclic process, and option D is all of these. For 38, the heat capacity at constant pressure is related to heat capacity at constant volume by relation. So the option A is molar heat capacity at constant pressure Man's gas constant is equal to molar heat capacity at constant volume, and option B is molar heat capacity at constant volume. Man's gas constant is equal to molar heat capacity at constant pressure, and option C is molar heat capacity minus molar heat capacity at constant volume is equal to gas constant, and option D is gas constant minus molar heat capacity at constant pressure is equal to molar heat capacity at constant volume. So the right option from these four options, option C is the right option. Molar heat capacity at constant pressure minus molar heat capacity at constant volume is equal to gas constant. For question 39, the Clausius-Clapeyron equation help to calculate the heat of vaporization or boiling point or freezing point of a gas or liquid. And option C is vapor pressure at one temperature if at another temperature is given. And option D is all of above. So first option is the correct option. Clausius-Clapeyron equation help to calculate the heat of vaporization. And for question 40, in a process when enthalpy change in enthalpy is equal to 100 kilojoule and change in entropy is equal to 100 kilojoule per Kelvin to 400 Kelvin, then the value of change in Gibbs free energy will be equal to 0, 100 kilojoule, 50 kilojoule, 60 kilojoule. So the right option from these options, actually there is a D right option. If you calculate the Gibbs free energy by its putting these value into its Gibbs free energy formula, and then you can calculate the, you can get the value which is 60 kilojoule. For question 41, the collision frequency of a gas is directly proportional to the square root of absolute temperature. Option B is directly proportional to the absolute temperature. Option C is inversely proportional to the pressure of a gas. And option D is inversely proportional to the absolute temperature. So the option B is a correct option, where the collision frequency of a gas molecule is directly proportional to the absolute temperature. For question 42, the root mean square velocity of a certain gas at 27 degree is a meter per second. Its root mean square velocity at 927 degree is a over 2 meter per second, B option 2 a meter per second, and C option 3 a meter per second, and option D is zero point 0.6 a meter per second. So the right option from these four options is RD, where zero point 0.6 a meter per second is the right option. For question number 43, for a certain first order reaction, time is zero point 0.6 is 100 second. How long it will take for a reaction to be completed? 75%, 200 second, 400 second, 300 second, and 100 second. Actually, you can add the value of to find the rate of fraction or its completion time up to 75%. You can get by this value by adding this value into the formula and get the time for the time of completion after the 75%, which will be equal to 200 seconds. So the right option is option A. For question 44, first order reaction is 1/4 completed in 40 minutes. The time required for its 100% completion is alpha second, 1000 second, 2000 second, 4000 second. When you calculate these value by adding this value into equation, then you can get the answer which is 2000 second. After 2000 second, reaction will complete up to 100%. For question 45, the reaction A going to product B is a second order process when the initial concentration of A is 0.5 million and the half-life is 8 minutes. What is the half-life if the initial concentration of A is 0.1 million? So the right option from these four option, first option is 1.6 minutes, option B is 8 minutes, and option C is 40 minutes, and option D is 16 minutes. Actually, the right option is according to my calculation, the right option is option D, 16 minutes. And this is our today lecture. We will meet together very soon for a next lecture. Fi amanillah.